Okay. I think our next speaker is actually here, popped in briefly, possibly. So we can kind of keep our agenda moving forward. We have Evelyn Ju up next, I believe. Hi, Evelyn.
So Evelyn comes from us from IBM, where you're working on guardrails for agentic systems, which is really an interesting thing that I think so many people are talking about. And you're here to talk about agents in the wild. So I'm going to bring your presentation.
And if you want to just say something, we want to make sure we can hear you, Evelyn.
Yeah, hi. Can we?
Sounding great.
All right, I'm not going to have the chat up, so I'll answer any questions after. Hopefully that's okay.
Yeah, no problem. If we see an absolutely burning question, we can ask it if there's time at the end. Otherwise, absolutely, please hang out in the chat and answer follow-up questions.
All right, take it away.
Beautiful slides.
All right. Thank you so much for having me here. I'm really excited to be here to talk about, among other things, guardrails in agents. And I'm Evelyn. I'm a software engineer in IBM Research, and I've basically been looking at, with my team, different platform level issues for agents. I started my career more on customer-facing NLP applications, and from there moved more into the trust in AI space. So a lot of what I talk about is kind of in the lens of creating trust in AI however we can. So to start, as other speakers have talked about today, AI workflows, AI harnesses today are growing more complicated, more sophisticated. Solutions like OpenClaw that you might have heard about, basically like a single user request can start to fan out into all these different multiple spawn sub-agents and all these different tool calls. So for example, if I'm a developer trying to patch my vulnerabilities, my CVEs in my GitHub orgs repositories, I may have all these different agents looking at the repositories, researching the vulnerabilities, and doing the actual remediations. And so each of these agents can pretty much, to some degree, operate independently of each other with their own context. They're not necessarily really tracking each other. And so there's, as we've talked about in earlier presentations, there's a lot of non-determinism also from these agents calling these LMs. And so even if you make the same call, the same request as a user, your agents might not make the same decisions every single time. Unlike traditional microservices, you could usually go back to debug, look at the particular code, see why particular calls were made, why your vulnerabilities would show up, and so on. And so how can we start to enforce security and observability in all these agent and tool calls? It's difficult to do so at the individual agent level, especially if your agents and tools may be owned by different people, different teams, or even third party. And so here we're going to talk about using a gateway as a control point, more focusing on the agent to tool call gateways. And this allows for one place for centralization and also instrumentation, especially when you don't own every part of your system with all the different agents, all these different tools, especially some of these tool servers may be calling out to third parties. And we're specifically going to focus on how we can enforce security at this agentic gateway layer. And so the Quadrant MCP gateway is just one example of a gateway, the MCP for Model Context Protocol for agent to tool calls. And this is, as I said, just in one of the implementations for MCP gateways. There's a lot of ones out there today for agent to tools. And there's also plenty of different gateways for agent to LM calls as well. And so for here, we're going to focus on this gateway that sits between the agents and tools after the users deploy a custom resource. This is part of the Quadrant project, which is a CNCF sandbox project, so open sourced. And this one is particularly built to be Envoy based. And so there's different aspects between the broker and the router that help you manage tools more effectively. For example, for discovery, this can basically help you gather your tools from different servers for your agent to call. The filtering is helpful if you want to only expose your agents to, say, a subset of tools, not necessarily force your agent to make a bunch of decisions between a bunch of different tools across servers. And then the prefix management is helpful if you want to, say, resolve collisions. If you have two tool servers that name the tools very similarly, how are you going to distinguish them? And then for the router, this basically makes sure your tool calls get routed to the right server that provide the tools, and can also help with enforcing authorization and authentication with policies on the tool requests. So today we're going to look at a couple of agent scenarios that we've seen to different degrees with agentic tools within like my own company, and some of these you may have seen some familiar headlines. So first, we're going to look at creating trust through token exchange with a situation where a lack of identity management led to an agent having escalated privileges. So say you're an on-call dev woken up at 3 a.m. from pager duty or however you're paged today, and the dev wants some help to be able to debug the prod problem. And so they may type to their bot in Slack that saying something like, oh, this customer is reporting 500s for HTTP errors for this particular service. It seems to be that this database might be having some issues. Can the bot help resolve this? And so here the bot may have access to be able to talk to this Postgres server to be able to try to debug the database with some credentials, including like some user and password to be able to access the database, and also like the actual database information such as the host name and things. And so in this case, the bot, when it tries to help the dev debug this particular problem, it may say something like, oh, the customer's last transaction appears stuck. Let me check the actual database using these credentials. And then it can use the Postgres MCP server to execute a tool call that says, I'm going to select the transactions from this transactions table where the customer ID equals this, that equals the ID of the customer. And so, great, it executed the tool call and it looks like the transaction status is stuck. I will try to resolve it. And then from this, it tries to do another tool call execution, basically trying to delete the problematic transaction from that equals the customer ID. And it says, great, the transactions are no longer stuck. But careful viewers may notice this particular SQL query from the tool call may in fact have removed more transactions than expected. And if you're the on-call dev, you may go, what happened to all of this customer's transactions? So what happened here, and why was the bot actually allowed to do this? The bot had access to some broad credentials that may have lived in a Kubernetes secret and is potentially overscoped for the use case. So what if the agent only had the same or fewer permissions as the developer invoking it? Usually as an on-call developer, you don't usually have access to be able to just write to arbitrary production databases, especially even if you're debugging it. And so at the gateway layer here, we can use token exchange in order to federate the workload identity, essentially provide proof of like who you are, who the developer is for the short amount of time for the agent to do a specific task. In this case, be able to access the database through the Postgres server tool call. And here the agent will be able to present its identity, such as a unique spiffy ID here that basically says, I am this agent running this particular workload right now. And the gateway can use a token service. There's many popular ones out there, including not limited to HashiCorp Vault. And then this can basically cryptographically verify the identity of the agent and then issue a short-lived scope token, such as a read-only one that is appropriate for this particular developer to access the database. And so having this happen at the gateway layer really helps agents not have to hold on to like the individual credentials, like having the credentials live in a Kubernetes secret for like the entire team, for example. And this forces like the gateway to sort of earn the downstream access for the agent. And so now the bot here, the agent can connect to and debug the Postgres database with these ephemeral credentials and only have read-only access. And so we're looking at some of these problems around identity in our Agentic project, specifically the auth-bridge component and also that with the MCP gateway. And I'll talk a little bit more about and leave the links for our project at the end. It's all open sourced. And so this will hopefully allow you to prevent similar results to something that happened like earlier this week. Allegedly, like this company founder, Pocket OS founder, destroyed their production data with likely some sort of unexpected access to the agent, for the agent to the databases. And so next we'll look at a scenario where you may want to guardrail content coming back to the agent through tools. And so here we'll look at an automated code assistant scenario. Basically, a dev may be wanting to try to debug some failing integration tests for a particular repository and type to their bot on Slack, can you please help with these failing tests for this particular repo? In this case, the agent may want to talk to both Slack and GitHub through different tool calls, have access to these servers. For the Slack case, this would make sense if the agent were trying to read Slack, get all the different thread replies, be able to post messages and so on. And the GitHub access would be important to be able to search for the repositories, get the information about the failing tests, like look at the GitHub actions, for example, and then be able to, if it were to update the code, create branches, update files, create pull requests, and so on. So in this particular case, the agent may be accessing the particular repository, looking at the GitHub actions and see, oh, like this is the particular file with the failing integration test result. Here it says, oh, there's an import failure that caused my integration test failure. It couldn't import this particular verification function from my utils. And this may come from a dependency, something that like the dev themselves are not super familiar with. And so the bot is going to go check the dependencies and has found the repository with this particular function and is going to try to look at this repository to see if it can try to resolve what the problem is. And it may try to read one of the files in the dependencies and see something like, oh, there's a deprecation notice. This particular function has been removed. The migration advice is to be able to remove all usages of this particular function and its associated tests. Not too far-fetched. Basically, when this result comes back from the GitHub's tool call from the GitHub MCP server, the team bot agent can essentially interpret this as, okay, I'm going to follow these directions. I'm going to remove the usages and its associated tests. I'm going to do this by removing this particular file and say, great, I have put these changes in this particular PR for the repository. All my integration tests are passing now because in fact, the failing tests don't exist. And the busy dev may say, great, everything looks green. All the tests seem to be passing. I'm just going to approve this PR. So what if we can identify these problematic lines before they come back to the agent and potentially get misinterpreted? In the scenario just shown, we can provide guardrails at the gateway layer as well and block results coming back to our agents. So we can add guardrails as plugins after the MCP gateway routing. In this particular case, basically after the tool name for the tool call is already identified. And so we can have a solution like an extra server or xproc here that can talk to a plugin manager, which can invoke these different plugins on different MCP primitives. So whether it's tool calls, prompts, or so on, these different hook points could require different plugins for flexibility. For example, on a tool call request, maybe you want to just check that there's an allowed tool based on a list. But on the response side, you actually want to be maybe more careful, check the actual content that is coming back from the tool, such as in the scenario we just looked at with the GitHub tool result coming back with this README information. So all of these plugins, guardrails that are provided here, as long as they conform to a particular API, they can have all sorts of different implementations. They can be very simple rule-based ones, let's say checking PII with a particular regex, can be pretty simple. And you can have more complicated ones with like AI-based ones, whether it's transformer or encoder models to do prompt injection detection or content moderation, or as complicated as LLMs themselves. That like examples are like ShieldGemma from Google, for example. And so in this particular infrastructure pattern, when a request comes in, like a tool call request comes in, it will, if all the plugins say, great, this looks okay, the plugins will allow this. The request will then get passed on sort of as usual to the MCP tool server. It will come back with a response. And the same or different plugins can be used to check the response as well. And then if there's an error, we return it to the user at any point. If it's if it looks okay by the plugins, we can basically return that and continue with the rest of the agentic flow. So as an advantage here, being able to provide guardrails at the gateway, it can assure more consistency across agentic systems, especially if there's a bunch of different agents, different tools. For example, you can, if you're trying to sort of prevent PII from getting passed around from agents to agents, agents to tools in your system, you may want to have a consistent definition of PII, or personally identifiable information, that you guardrail from going to your agents and tools. And next is, what if this bot was a third-party app and you don't have access to all the particular logs and debugging ability? So in the same scenario, when the dev is trying to debug the integration tests, if you didn't have any access to the logs, or you would only just see the end result, which is the bot changes were made in the PR and all the integrations tests are passing now, and the dev looks at all the green check marks and goes, okay, I'm going to approve this PR. But if we had some trace observability at the gateways, we can track a little bit more information, even if we don't have access to be able to update or change the agents and tools themselves. So you may end up, unfortunately, with the same result maybe on the first pass, but on retrospective, you can be able to identify different amounts of information that can allow you to make changes to your system, which will be very important if you continue to run agents. So at the gateway level, you can potentially get information on all the different tool calls that were made, starting with, okay, it used the Slack tool to be able to read this dev's Slack thread, what authorization maybe at a high level was used to access the GitHub server. You can potentially see, okay, like this was potentially a overscoped team token. Maybe I shouldn't continue to use that in case I get escalated privileges, like in the first scenario we saw. And as the flow goes on, you can observe more of the different tool calls that were used to access the GitHub server. So this can include like checking the particular GitHub action with the check run and getting the file contents, which repository was accessed, which particular files were accessed, in order to get that problematic README, so we can trace and see what had happened there. So what are the components doing here is something that we can answer. You will likely want some degree of OTel or open telemetry instrumentation at the agents or tool call levels, but providing a lot of the spans at the gateway level will also allow you to centralize the instrumentation and get information consistently. So some of the information that you may want to gather at the agent level may include the particular LLM or model that was used. And so there's strategies like OpenTelemetry's recent or somewhat recent zero code instrumentation that can modify Python functions and so on to make this easier. You don't have to go through and like add OpenTelemetry code in detail to all of your agents. But essentially, if you're calling an LLM from the agent, your LLM might be running somewhere else. You may want to log this information, whether at a gateway between the agent or the LLM, or just essentially have that information be able to be provided. And this will include information such as like the actual LLM called and the parameters that were used to call the LLM. So, and information that will come back will include things like input token usage, output token usage, and all of this could be helpful for things like billing reasons. And these other spans for the gateway and the server tool server level, you may want to include are like the actual methods being called, the tool names being called, and the tool calls, arguments, and results, and so on, and the MCP session as well. So all of these here follow the GenAI semantic conventions. They're somewhat recent in being defined in OpenTelemetry, but we're trying to standardize on particular conventions where possible. So once you have all the different spans from your agent, your gateway, your tools, the rest of this will follow pretty standard, I suppose. Observability architectures, you can have an OpenTelemetry collector, for example, to be able to receive, process, configure all of these different spans together and make sure that they follow a specific convention. And then you can forward all of these to a storage backend. Some examples are like Jaeger, Tempo, and so on. And you can have the same data going to all sorts of different backends. The exporters will handle your formatting, protocol conversion, and so on. And for some of these solutions, they will have front-end queries where you can visualize your traces, be able to essentially connect all of this information from when your one user request, for example, be able to trace that from the agent through the gateway to your tools. And for anyone wondering, with all these different patterns affecting agent communication, how will they affect Kubernetes APIs? So in one of the subgroup projects under SIG network, where SIG is also a special interest group, so a subgroup of a SIG in Kubernetes, we are looking at providing standardized APIs for secure governed communication for the next generation of AI agents. So a lot of the focus has been on the agent to tool communication so far, but essentially we want to look into providing APIs for agent to LLM potentially as well. So all of this is happening upstream, and I'll provide some links at the end as well. And so we basically shown the gateway as a control point for all these different aspects, the workload identity, the guardrails, the observability. And for each of these aspects, there may be different questions you want to ask of your agent systems, especially if you're a developer or engineer deploying all these different agentic systems. For the workload identity, can you revoke a misbehaving agent's credentials very quickly? Let's say the threshold is about a minute. Can you revoke these credentials without affecting your other systems? Like if you had to revoke a Slack API key, is that going to affect all the other agents that your company uses? For guardrails, can you block an agent from just blindly following malicious instructions and files it reads, especially if it has access to random parts of the internet to be able to gather information? For observability, when an agent misbehaves, can you actually trace what it called and who, especially which human user triggered it? So I've shown all these different patterns to enforce security policies at the gateway layer, but today's gateways have some gaps. In a later session, I think about an hour and a half from now, Morgan Foster and Keith Mannix will be tackling the questions of the gaps in gateways today from the AI Gateway Working Group in Kubernetes. And they'll be talking about how the gateways are affected by people wanting to add AI-specific policies and how we start to address those gaps. So as I talked about earlier, a lot of the workload identity, guardrails, observability we are looking at in our Agentic project. There's basically, it's an experimental platform for demonstrating what agent management on Kubernetes can look like. So the leftmost QR code here is our website, and then we've just moved from Discord to Slack, so relatively new Slack community that you can join here, where we talk about what problems we want to explore in agent platforms going forward. The link at the bottom there is for a Quadrant project that had the MCP gateway I talked about briefly. And then on the right here is the website for the Kubernetes Agentic networking group. And we're also on the Kubernetes Slack at SIG network, Agentic networking. And then if you're not on the Kubernetes Slack, you can send an invite to yourself to join through slack.k.io. And so thank you so much for your attention today, and I'll take any questions.
Thank you. So there are a few questions. There's a really, really long one that Michael asked.
I think Vlad had one. Yeah.
Are there ready to go? Nope. Are there ready to go open source projects, control planes that utilize common interface to orchestrate different types of agents on Kubernetes? That was really early in your talk.
Yeah, so I would encourage you to check out our project. We tried to focus on standardized protocols where possible. Obviously, we know A2A, agent to agent, MCP, model context protocol are super popular today, but I think everyone knows how quickly this field moves. The protocols that are very popular today might not be popular in the next few months. And so we're focusing a little bit more on those particular protocols like Agentic for now, but like especially in the upstream groups, we want the Kubernetes APIs to be very, I guess, not affected by changes in protocol. So we're focusing more on the user stories for that. And so if there's any ideas there, we'd love to hear them.
Okay. There is a question about identity, authorization, access scoping in multi-agent, multi-MCP architectures. The first part of it is pretty IBM specific, so maybe you can answer that one in the chat afterwards. But there's a question about scaling identity at MCP. What are your recommendations or blueprints for managing workload identities at scale, specifically when dealing with hundreds of MCP servers?
Yeah, so we're looking at how much we can gather sort of just around the agent level and using the gateways to be able to scale this for all these different servers. So the gateway that we use, the MCP gateway, is one of our solutions to be able to account for that and not have to focus too much on the MCP server specifics. So would encourage people to check that out as well. It's specifically one of the specific components in Agentic is the auth-bridge project that we're also looking to scale identity.
And then he just had a follow-up about the bot level access scoping. So if there's multiple bots with different permission scopes and they share the same MCP server, like how would you handle access controls at the bot level?
Yeah, I guess for the bot, I would say we're trying to focus less at the bot level and sort of be able to say, like, can we map the different users with their different permissions, sort of like a Google Doc. If some people have read access, some people have edit access, how can you translate that to the tokens that are able to access, like the Postgres server, for example? If you only have read access, how do we translate that to read access on the server, right to write?
Yeah. Okay. And then there's another question. Would the agents be a container or be in a container in a pod, or multiple functions is a container in a pod?
I guess here you can say we were trying to be very restrictive on whether agents can particularly only be like one pod or maybe even one deployment. And so all of this should be able to apply, but mostly a lot of what we test for simplicity and be able to like run on, say, your local machine on Kind has generally been like, okay, one agent pod is much easier to like debug, let's say.
Okay. And then yes, is Quadrant mostly targeted agents running as workload with identities, or does it also address agents running in local developer machines such as Claude or Cursor?
So I guess we have work in progress to be able to scale to like more of the complicated agent harnesses, like whether it's Claude Code or Cursor. So that's kind of work in progress that we're focusing more on. So if you're curious about that, like feel free to join the community, talk to us about it.
Awesome.
Great.
So we might not have summarized all those questions accurately. So if you wouldn't mind,
I will try to
go back and read through them.
Yeah.
There was some more detailed and follow-ups, and then you can use the reply feature, or you can just, I'm sure everybody would like to know the answer. So you could also just reply in the main thread, maybe just at the person who asked the question, so we know which question you were replying to.
Okay.
And thank you so much. That was super interesting.
Thank you for having me.
All right.